This is the learning path that's going to take 3 hours to finish, but we're not going to go through all of it. We're going to start with the introduction to Azure Synapse Analytics, and we're going to look into specifically into SQL Serverless. So what are we going to cover? We're going to cover what is Azure Synapse Analytics, how does it work, and also where we can use it, right? Right. So what is Azure Synapse Analytics? Simon, I think, by now, most of us already kind of get an understanding of what can we do. It helps us, it combines big data with data warehousing, with analytics, with real-time and visualization, and all this good stuff into one place. But where should we use it? I mean, what is descriptive analytics?
So it's a real... After you, go.
Go for it.
So it's, whenever people are starting, it's always kind of just this, where do I go to do all these different jobs? There's so many different things in terms of Synapse that where they can actually sort of get involved. So descriptive analytics is just trying to understand the current state of things. And you get this kind of maturity curve of behind where you want to be, and just being able to do just traditional stats, what you see from a warehouse. How did my product perform? These are all traditional like warehousing things. And there's elements of Synapse that are perfect for doing that, building out a warehouse.
Yeah, absolutely. So there's the descriptive analytics, there is the diagnostic analytics, and here we have a diagram that can help us, understand things maybe a little bit better about how the two combines and how we can use all of them together to kind of bring more insights and value into the projects that we build. So I hope I'm getting it right. Please help me if I don't. So we have the data, right? And then we have multiple analytics that we can take. So we have the descriptive, the diagnostic, the predictive, the prescriptive, and so many questions that we can ask ourselves when we work with that data related to what we want to get out of it. And all of that can help us with doing the decision making process. And we often talk about data-driven decisions. And I think this is where it really pops out. It gives us the different questions that we can ask from our data to better do our data decisions that can help us, I guess, take better actions, right?
Yeah, exactly.
All right. So we talked about the descriptive, diagnostic, predictive, what will happen, what should I do, why did it happen, and also how it helps us. So how is the Azure Synapse Analytics works, right? How does the architecture looks like when we want to work with it? So we know on the top there is something called Synapse Studio, right?
Yeah, exactly. And that's one of the big things. There's so many different parts of Synapse that it's a little bit overwhelming when you look at that picture and you're like, okay, we've got a bit of Spark, a bit of SQL, a bit of serverless speaker. You've got all these different bits and pieces, but it's all in a single workshop. So you've got the Synapse Studio is just that nice one-stop place you can go for all of these different things.
Okay, so this is slightly confusing, to be honest, because I know we talked about data strategy and we talked about the monitoring and the fact that you have to save your data. And then I see SQL and Spark, and maybe I don't know anything about Spark. And then I have provisioned and on-demand and, SQL, Python, .NET, Java, Scala, R. Do I have to know all these languages to be productive with Synapse Analytics Studio?
No, you don't. Obviously, the more you know, the more you can get out. But it's more that because it's set and settles so many different use cases, you can just use it for the slices that make sense for you. It's not that you're spinning up some gigantic thing and then having to use every single bit of it. Or back in the old days, you used to spin up buy a physical server and install an application of it, and you have to make sure you use all the parts of it. It's all pay for what you use. So spin up the bits that are right for your use case, and then just pay for what you use.
Whew, this is a great relief. So I don't need to know also Python and Java and .NET and everything involves. I can just jump in there and use the things that I need.
Exactly.
Perfect. All right, and we can see here there's Apache Spark pools that supports all the goodness from Apache, and also the .NET from Apache Spark and the .NET as well from C#. And we can see we can do data integration with pipelines. And one fun fact about the pipelines, they support no-code, low-code. We don't have to write code sometimes as well. Yeah, near real-time hybrid transaction. Simon, what is near real-time? What does it mean?
So often people are trying to do the full streaming. So every time a single little event comes in, you update it and you have a ticker on your graph and all that kind of stuff. And building a stream-only architecture, it's quite hard. It's really hard to just build it and maintain it and manage it. And what we've got with the HTAP, the hybrid transactional analytical processing in Synapse Link, is near real-time. So it's not kind of absolute instant every time every message comes through. There's kind of a regular couple of minutes later, you'll have tables that are updated, but they're updated like asynchronously. You don't have to go and do anything. So you can have a Cosmos DB, and it can have lots and lots of live reads and writes happening with the application. And then you can be writing queries in Synapse directly over those objects in your the collections in your Cosmos DB, and it'll be updated. The data will be a couple of minutes old, so near real time, without having to do any ETL, any of the normal extractions, any of the engineering to try and plug those things together.
Okay. Sounds cool. You know, I'm excited. And now we can see there is the Synapse Studio that we can hop on. So let's open the Synapse Studio and see what we can do with it. Let me share my Synapse Studio with you all. All right. Let me bring it up. Here it is. So you can see, well, first, this is the Azure portal. I mean, this is where everything starts, right? So I already provisioned my Synapse service. So it's right in here, and I can see I have built-in serverless, which I didn't create. I mean, it comes with the Synapse. I don't pay for anything until I use it. But I'm actually here. I want to learn about the Synapse Studio. So let me share the Synapse Studio. Here it is. Click the Synapse Studio, and now it's opening. All right. So like we talked before, there's multiple pools, and there's multiple things I can do right in it. And I think one of the first thing I've noticed that there is a learn box, and I'm like, hey, wait, why inside a service there's a learn box? What does that mean? So I click it, right? And right here I can see different boxes like use samples immediately, browse gallery, tour the Synapse Studio, and many things I can learn. So I noticed it jumped into the Knowledge Center. So what is the Knowledge Center?
Well, it's exactly that, right? It's a whole load of documentation and tutorials and built-in samples. So if you're trying to get started with Synapse or a particular part of it, it's probably get a tutorial and example in there. I mean, so certainly kind of if I'm having a play around, I'm like, how does that thing work? One of the super useful things inside the samples, there's a load of data sets. So if you're kind of having to worry about kind of creating some dummy data and getting it to work, and then you can try something, the samples are super useful just to go, you know what? I just want to take a pre-built query, a pre-built notebook, a pre-built bit of work, a demo on top of some data, so I don't need to think about doing that. It's a really nice way to just get started and start experimenting and having a play with this stuff.
This is fun. I really like how it evolves. So I can learn directly from the studio. So let me share my screen one more time. Let me see that I'm getting the right one. All right, because I've noticed there are multiple screens in here. Okay, cool. Awesome. So directly from the Knowledge Center, like you mentioned, I can learn, and I can also use open data set that already exists. So I press the use samples immediately, and I want to learn today about query data with SQL.
Yes, exactly. So that's going to be a little sample script about serverless SQL. So we can use that new SQL on demand serverless kind of and step through and understand how that works.
Awesome. And I see right here on the top, there's a full tutorial available under this link, so I can click it.
Yes, exactly. And we'll go back to that. We'll use one or two of the things from the full tutorial just to kind of take it a little bit further.
All right, so let's see what we're going to do here. We are working with the New York taxi data set that includes a lot of different features and a lot of different queries that we can run on it. And there is the automatic schema inference. That's interesting. What is automatic schema inference?
So if you're coming from especially from a traditional SQL background, you'll be so used to having to tell everything the structure. So to be able to say, I'm going to create a table of data, you need to say, these are the columns and these are the data types. And it's the same when you're doing things like Polybase, you're using kind of a load of the tools that we already have for going off and querying data. Normally, you have to, again, tell it the schema. I'm querying a file. These are the columns I expect to see. So automatic schema inference is saying, I want to query some flat files, but I don't want to have to tell it what it's going to find. I want it to start reading the data, look at the data and go, based on that, here are the columns, and then present it to me. I want it to be nice and flexible so I don't have to specify stuff in advance.
Okay, that's really cool. So it means I don't necessarily need to define the schema, which is really awesome because, sometimes when I want to explore the data, sometimes my data is just sitting there and I don't really have a lot of insights into it. So I just want to let it run and start exploring. And I just ran the first query of select top 100 asterisks from open raw set. What is open raw set?
Okay, so open raw set is essentially calling one of the flat file resources, saying I want to open something as if it was a table, as if it was a subquery. So it's kind of the same way as saying from subquery go read another table. So open raw set has a bunch of different data readers built in, and that's going to use this kind of the new engine behind serverless SQL, which is going to be able to understand data in different ways and go off and query it. I think we might need to zoom in slightly for the people at home if they're kind of following along.
Yeah, absolutely.
Yeah.
There you go. All right. So
you can see the data set below. That's a flat file. So that's data that's sitting off in someone else's layer. So this is kind of a data set kind of shared by the Synapse team. And you can just go write a query against it. It looks like a SQL result set that you've got back. But that's coming from a thing called Parquet.
All right. You mentioned a lot of things. What is Parquet?
Parquet is a column store flat file. So if you're used to using SQL Server and you've got a column store index, which instead of storing the data going each row is stored kind of sequentially, so it has all the different columns. Instead, it stores it. Here's all the different values for all the different rows for this one column and different columns. And what that means is you can compress it really, really, really well. So it can do stuff if it sees the same value like 10 times, 100 times. You can go, well, it's that value for the next 100 rows. And suddenly the data gets squished much, much, much smaller. So Parquet is column store in a flat file format, but it is awesome for writing analytics queries, for doing aggregates, for doing distinct counts, for doing min, max, all that kind of stuff. So Parquet is a fantastic data set for data lakes.
All right. You got me hooked. I'm going to use Parquet for the rest of my life.
Good.
All right. And now I see there is something around time series, seasonality, and outlier analysis. And this is interesting because we are talking about New York City taxi data set. So I wonder what kind of seasonality or time series we can get out of this. So the first query will help us summarize the yearly number of taxi ride. So let's give it a shot. So while I'm running it, Simon, maybe you can help me understand what's going on now behind the scenes.
Okay. So there's a few different things going on here. So one, this is using that new engine, that Polaris engine. And there's a super, super interesting white paper that we'll kind of drop the link for. Which is all about how this new engine works behind the scenes. And it's a distributed query engine, it's a really hard thing to think about coming from traditional SQL Server because it's so different what's actually happening. But in order to do essentially what a full-size SQL servers do, right? So if you have a SQL server that you've put on-prem, or you're logging onto your normal SQL server and you run a query, you kind of know what's happening there. You kind of know how many CPUs you have. You know, it's got one box, it's got all the data. Yeah, kind of knows how it's splitting things up. And then we moved on to SQL Data Warehouse, which is that MPP style. But even now, I'm saying I've got 2 compute nodes, I've got 3 compute nodes. I've got a fixed number of servers, but they had to do a load of work to say this is how you query some data, and then do that bit of compute does that those calculations. That one does those calculations, and you have to split it up. And now, in order to do serverless, in order for it to be, it's returning results in kind of a couple of seconds. But you're not paying for a cluster. There's no compute sitting there. There's no server that you're paying for that you're just using application from. So they've had to build this whole way of saying, take this query, break it up into lots and lots of different chunks, be able to read things like Parquet. So you can say, that bit of data read that bit of Parquet, that bit of data read that bit of Parquet, but do it across millions, thousands and thousands of servers in real time and pass it back to you. So it's just a whole load of stuff that's going on behind the scenes when you're running that query, which means it comes back in a couple of seconds, which is awesome.
Yeah. Wow. All right. So much engineering going on into it. I did take a look at the Polaris article, and the first thing I've noticed is the cloud native approach. They separated the compute from the storage from the state. This is like the first thing everyone needs to do when they want to work with the cloud, and they want to go with the cloud native approach. So I definitely love that. But hey, you don't have to be an expert on these things because we have these tools, and you can definitely leverage them. All right. So I noticed I ran this query and I got some information back, and I've noticed that in 2014 we had plenty of writes, but here there is a drop. I can see it by the missed digit right here, because this is how I'm looking into things. And what happened? What happened from 2014 to 2019?
So that in itself is fairly hard to read. So you do have the table and chart. You can click on chart, and then we can have a look at what that data looks like visually. And we can see that it's going down. That's nice.
Whoa. It's significantly going down.
It is.
It's not like a tiny bump.
I think in the data they explain that this cut was taken halfway through 2019. So it kind of makes sense that you don't have a full year's worth of data, but we can dig into it. And that's that kind of analysis, just to do really quickly, just write a query, not wait hours for the result to come back, but just write a query, look at something, visualize it, and then be able to explore it and be able to ask more questions and dig into it. It's exactly kind of the story we're trying to tell.
Yeah, so I opened the full tutorial because right here in the studio, we reached the end of the tutorial, but it did take us to a link where we can see the full tutorial about the time series, seasonality, and outlier analysis. And I think here they plotted it really nicely. So you can definitely see how it's going down. But I think the next question, I want to know if it's what happens. In 2016, this is like one of the year we want to focus on. And you want to understand a bit more, what can we tell about seasonality within the year, right? So if we can find some patterns inside the year of how people are using taxi ride shares.
Yeah, and that query's got some interesting stuff. So let's put that in, and we'll talk about what that's doing.
All right, so I pressed the copy, going back to my studio, and I'm going to drop it right in here and run it. All right, so it's going to start executing, but first we see there is a casting operation, and there's some value coming back, and we're casting it as date. There's a count for rides per day, so we're going to look at, for every day, how many rides people took at that day, and we know, what is this? What is all the asterisks right in this file path?
So that's the joy of partitioning. So whenever we're dealing with a lake, joy. I love partitioning. I love it too much. Whenever we're dealing with data in a lake, we don't have some of the things you normally have if you're in a SQL Server. We don't have a clustered index sitting on top. So if you want to say, I only want data that's in 2016, traditionally in a lake, it's just stored as files. It doesn't know, well, that file has that data in it, that file has that data in it. There's no structure if you're just talking about flat files. And so over time, this kind of a partitioning style has evolved, which is folder-based. So you put data that pertains to different years in different folders, and you name the folder with that. So you can say, well, this is my 2015 folder, my 2016 folder, my 2017 folder. So you end up with kind of like this big folder structures with, kind of folders and subfolders and subfolders. And things that are smart when they're reading lakes, they understand that. You can say, well, I want my year to be 2016, and then it won't try and read all the data that's in the other folders. It'll just go to the folder that it really cares about. So in the folder structure that you had there, you have that kind of stars. We've got that kind of where PU month as the pickup month equals star. And so that's saying, well, actually, I want to read everything. I don't want to have a particular thing. I just it's a wild card, like saying, select star from. It's saying I want to pick in all folders that are there. So that's super flexible. That's saying just take any data I can find and go through and understand it. And then you can see, and we've got that kind of, you might want to zoom in a bit more onto the where statement. You've got that file path, which is a special command here. So NYC, that's our table. So the whole open row set thing we've said as what NYC. So we're referring to inside that subquery. And then file path is something that doesn't exist. That's not a column. So that's a special system variable saying file path. And then we've got a number in there. And that number refers to the number of the asterisks we've got. So essentially, we're kind of referring to certain pieces of that kind of path string. So we've got file path 1, saying the first asterisk we see. So we've got in there, we've got NYC, we've got yellow, we've got PU, year equals star. So by saying where file path 1, I'm saying where the first bit of that file path equals to, and then you can see we've got equals 2016. So that data, when we actually look at it, we'll see several different folders saying pickup year equals 2014, pickup year equals 2015, pickup year equals 2016, and then saying where the file path is 2016, we're referring only take that folder of data. And that means it doesn't bother reading the other folders, and so it's much, much quicker.
All right, got it. So now actually we can play a little bit with the Parquet file and see how we can get the different partitions work for us as well. I mean, I can pull in an asterisk and pull in everything that I want, or maybe I can specify and give it a specific file like 2016, right?
Yeah.
Right, let's look at more of the queries. I'm interested in where we're going. So here they actually combining two data sets. They're saying, okay, we noticed here on the studio, we noticed there is some pattern going on, but we don't know what all this drops mean. I mean, it comes and goes, and want to try and combine it with holidays data set. I want to say maybe it's a holiday. So I'm going to copy that one, paste it here. And let's try and understand what this query does. Simon, I will need your help. I see multiple select here and a join, left outer join, and pulling out from open raw set and all this goodness. So what is this? Is this something, I mean, this query seems familiar. It looks a little bit like what we've seen before.
Yeah, so essentially we're taking that last query that we ran. So we can go and get our data, our 2016 taxi data. And we're wrapping it in a thing called Common Table Expression, or CTE. Now, if you're coming, again, from SQL Server world, it should be super, super familiar. And it's really good to see that we've got that kind of that level of SQL support. It is kind of full SQL Server style querying that we can do here. So it's saying we want a table called taxi rides. That's our first one. And then a table called holidays, something along those lines, public holidays, that has a different open row set. So we combine different flat file sets and run a query over.
All right, so let me copy it again. I don't know what I did, but let me go back here and create a SQL script and paste our query again so we can run it. Oh, and I'm using the built-in. This is how I know I'm using the built-in serverless SQL. And I'm going to run it. All right. All right, so here we're doing left outer join, and we're combining data from two different tables that we pull the data now, right? So we pull it again, and we're combining it, and we're trying to order it by current day. So what does this data tells me?
So we're now seeing if any of those particular days, they had a public holiday on that day. And that's great, because it means we can see if there's any particular drops, what were those days? So maybe we could do something to make that easier to see. So we could change the order. So we could order that by the where the minimum rides per day, and then we'll see, were there any ones that, are they all on holidays? Or maybe there's some that actually don't. Maybe some of them actually, we don't know why there's a problem there. So we can change the order by statement. It's currently saying just by parent day, so we get a nice by the calendar day. And we can change that so that's by rides per day. And then we should be able to understand where are the minimum, where are the low points, what's going to happen in there.
All right, so I'm going to copy the rides per day and order it by, whoops, rides per day. Here it is. And I'm going,
yeah, and that's great that it's got IntelliSense. It can understand your query as you're writing it and pull out things in your subquery. It's nice.
yeah, it is really nice. I mean, I don't have to remember all the different fields that I just declared, and it's fun. All right, so I'm running it and ordering it by rides per day, and I'm getting an interesting response. All righty. We see this one is null and null. Okay, this means there was no holiday in these days.
No holidays.
Yeah, null holidays. Not relevant for December anyway. We do see there's a Christmas day and Thanksgiving and a lot of days here. All right, but I don't see
that's kind of interesting, right? So we can see that most of the low points were fell on holidays, but those two first days, I mean, they're just low. There's not a public holiday. There's no reason why people would be traveling less on that day. So that's kind of like there's something else. We don't have enough data to understand what's happening on that day. So we can try and do something else. We can try and pull some other data in. We can look somewhere else. But yeah, kind of that, as an analyst, that would be kind of, that's the kind of the story we're telling here, right? You know, kind of you can run a quick query. You can bring in a data set just by landing it in a blob storage, landing it in a lake, something that can Synapse can see, write a query over it without having to pick it up and save it as a table somewhere, without having to create a structure, create a database project and deploy it. You can just write a quick open row set. And then it's kind of this iteration is kind of what we'd expect to see, right? Kind of you ask a question, doesn't quite answer that, ask another question, see if we can drill down.
All right, sounds fun. I mean, it's, you know, this is one of the main things that sometimes people need to do is basically explore the data that sits offline somewhere in a data lake. You know, just some people drop the data there, and now we need to pick it up. And before we do anything with it, and if it can be machine learning or analytics or anything related to that, we need to start understanding a little bit what's the patterns where we're going with it first. So I really like this tool because it makes it super simple to do the first
absolutely.
data exploration. All right, and we noticed there's still some weird dates there in the data, like January 23rd, and they prepared a query for us to start running. So let's drop our query in here. And start running it. And in the meantime, maybe you can, you know, explain a little bit of what all this functionality means. What is the average, mean, max on different fields? What does it do?
I mean, so a lot of these should be super familiar to anyone who's used to writing SQL. You know, so there's a whole bunch of standard aggregation functions that are built in so that we can, I mean, you can use it as a window function. So you can write it, so it's on a partition section of it saying, show me the average just for this rolling day, show me the average for a particular kind of group or particular region. Or you can do it as we are here, just saying, I want to see it over the entire data set. So we've not given it a over partition by, order by, any of that kind of stuff. So we're just basically getting some stats the average value, the highest value, and the lowest value for a bunch of different stuff across some weather data. So in this case, we're not joining it back to our original data set. We're just saying, you know what, there's something funny about that day. So we've got some weather data. So let's just bring back the weather data for that particular day to try and understand what's going on. So was it particularly hot, particularly cold? Was it raining? Was there something that happened on that day that might explain this? And if it did, that might then, maybe that's something that we can eventually build into analytics that we're doing. Maybe if we know suddenly, if we're a taxi company and we know that when this weather pattern hits, suddenly all our sales drop, we can prepare for it. We can actually say, well, maybe we don't need as many drivers that day. Maybe we don't. We can do something else with our fleet that day. Maybe that's the day that we book maintenance in. So you could build, kind of finding out these patterns, finding out what caused this problem. Maybe that's something we build into an ML model in future. So we look at predictions and then we go, oh, it's going to happen again. Let's try and react to it. And then it turns into that kind of prescriptive analytics. So this is kind of descriptive analytics going, what happened in the past? And we're trying to identify things that we can use to predict what happens in the future.
I love it. I love how easy is it, for me to jump in and do my prescriptive analytics right in from this with the serverless SQL approach. Because hey, I didn't spend any SQL pools. I don't have any Apache Spark pools in it. I'm just running my queries into my built-in serverless. And that kind of, it's fun, but it's also worrying in a bit because it means I'm paying here for something, right? And I don't know exactly how it works. But before we'll jump into it, I notice our query takes some time, and maybe we can try and make it faster. You did mention something about reading all the data with these asterisks here. So what can I do to make it better?
Yeah, okay. So yeah, this does seem to be taking a long time, right? This is going off doing a lot of work. It's obviously doing lots under the hood just to bring back a single day, which is like, that doesn't seem efficient. There we go. That came back. That took how long? About 3 minutes, which isn't the fastest query. Now in this case, it's probably because it's reading way too much data. It's doing too much work before it then starts looking at years or months, kind of our aggregate stuff.
All right, so you told me to bring in a single day, and I specifically asked, hey, go to the New York City data pool, and on the file path, go to 2016.
Yeah,
right?
exactly.
This is how.
We've got our first asterisk that we're using in that path. So we've got that pickup year, exactly as we did before, saying rather than reading all years, you've said nyc.filepath1. I just want to do that first one. We need to change it from NYC. It should be weather, because we're pulling from our open row set is our weather table. So it'd be weather.filepath1. We'll point to that first asterisk that we've got.
So is this the right query? Can I run it?
No, so that first bit of the where. So when we've got nyc.filepath, in this case, our open row set query, we've said as weather. So our little table or subquery is coming back as a thing called weather. So it needs to be weather.filepath.
So
and then it'll look at that string.
This one here.
Oh, no, sorry. So instead of NYC, we need to replace that with weather.
So, right. Here it is.
Yeah, there we go. Because it's just a subquery. So we're saying that subquery, it needs to be filtered where that file path is. Now that's going to read, it's going to read everything it finds inside 2016. And so it's still going to read every month. So we could make it even more efficient by saying, and where the month is equal to 01. So we can kind of, we can filter it in several different ways. And that's kind of narrowing down the amount of data. Rather than reading all our years worth of data, we're just reading 1 year's. And then instead of reading all of our months worth of data, we can just read 1 month. And it just gets much faster and more efficient as we kind of do that.
Yeah.
And that's kind of, it's a tricky thing because we had a date filter in there, right? We said date is equal to that 1 day, but that doesn't know how that date relates to those year and month folders. So it's really important to get used to thinking in terms of those folders.
Got it. And we do have questions from the audience. Someone saying he is new to data science. What are we doing here? So what are we doing here? Which part of the data science is it? I mean, we're doing data explorations. We can't create any machine learning model without first and foremost understanding our data and what's going on in our data, looking at our tables, trying to get a hint of the patterns. This is like the main step before we're jumping into creating machine learning model and injecting a model with tons of data. So welcome, and I'm excited for you that you're new to data science, because this is the first step that you will need to take in order to start jumping into and doing more machine learning, developing more machine learning models. All right, this query was super fast. I mean, the last one took 3 minutes, and this one took 14 seconds. I mean, this little tiny piece here did the trick.
And it's all down to how much data you're reading. The more data you read, the longer it takes, because it has to read lots. And that's the same as you do in SQL Server when you're looking at table scan versus index seeks and all that kind of stuff. It's thinking in terms of that partitioning is how you work with lakes to make things faster.
All right. So how do you know how much my query ate? How much data did
it's a good question. I mean, and that is literally the first thing everyone asks me when I kind of show them SQL Serverless for the first time. They're like, "What? Well, how do I know? How do I know what changed?" So we can go into the monitor tab over on the left.
All right.
Okay, yeah. And we got that thing called SQL requests.
Clicking on it, and I see it's loading. Well, I did do a lot of testing with this environment.
And there we go. That's super, super useful. We've got that full history of here's all the different queries you've written, here's how long they took, and here's how much data it brought back. So you can see that real quick difference between the two that you wrote, how much data.
So look at the last two queries. I mean, these queries did exactly the same task, right? From a logic perspective and from an answer perspective, they did exactly the same. They answered the same question that I want to, but they processed different amounts of data. Why? Like here we have 12 gigabyte. Yeah.
Purely because of having that file path in there, that limiting how much data you're bringing back. Now, you could have written it, you could have hard-coded the 2016 into your file path and said, I only want to run that. But it's so flexible, right, to be able to have, based on a where statement, based on a parameter, and then you can pass that in from a variable. So each time you run it, it's change a variable, and it's going to efficiently run for each one you're doing. But it takes a while to start thinking in those terms, that kind of folder structures and wildcards and that .file path. It takes a little while to get used to.
Yeah, I mean, absolutely. You have to know, if you work with Parquet, you have to know about partitioning and data shredding and what it all means, right? So it's fun that we can, start and running our query, but sometimes we need to be a little bit mindful into how we're structuring the query so we can get better performance. And you know what worries me here? And I did mention it before. I know that serverless is a fantastic feature, but it comes, it always comes with some price. I mean, someone is managing my servers. I know I'm not paying for a VM directly, but someone is using a VM behind the scenes. I mean, there's a virtual machine somewhere that runs my query and do all this great stuff. So how do I know how much I am paying? Because I want to give it to my data science to explore their data. I want to give it to my data analyst to work with it. I want people in the organization and in the enterprise to use it. But I also want to be able to monitor it.
You have to, and it's kind of the second question everyone always asks is, what am I paying, and how do I stop people? How do I stop people? How do I help people to avoid paying too much? And it's kind of a real big thing, kind of behind the scenes, saying, what if I run a query and my users don't know about that file path? They don't know about partitioning. What's to stop someone running a really big query that reads terabytes and terabytes of data?
Right, and that's going to bring me into the Synapse analytics pricing. And, there's a lot of things we can cover here when we talk about pricing, from having our own SQL pools, which means, if they're idle, we're still paying for them, right?
Mm-hmm. So dedicated SQL pools, you spin it up. When it's turned on, you're paying for it.
What about my Spark pools? Am I paying for it when they're up?
So Spark pools you pay for by the session. So you define a thing called a Spark pool. So you say, this is the maximum number of computers, server nodes that I want to have. But only when someone turns on a notebook, writes some code, does it actually create a session for them. And the sessions are the things that cost money. The sessions are the things that it says, of my potential amount of compute, I want to spin up 10 VMs, 2 VMs, whatever your session size happens to be, for the lifetime of that session. And then you've got various different tools in there, such as timeout, so it can idle. So if I spin up a session, I start working, and then if I don't do anything for 15 minutes, it'll turn itself off and I'll stop paying.
Cool. So I can actually be smarter when I work with it.
Definitely be smarter.
All right. And now I reached the serverless part. Ta-da-da! What's going on in serverless? I'm not paying for any pools because I'm not managing and I'm not working with any virtual machine. But I am processing data. So what does it mean? I mean, I see serverless right in here, and I see $5 per terabyte of data processed.
Exactly. So it's a priced per data read. So the amount of data that goes off and reads, or the amount of some processing does in cache, that's what you're paying for. It's the amount of work it has to do.
Right. So if I'll go into my Synapse workspace, and I'm in the monitor part under the SQL requests, and I can see this query here that took 13 seconds, and it kind of processed 906 megabyte in here.
Mm-hmm.
Then, well, it's way less than a 1 terabyte. I mean, it's so small. But yeah, this is how much data got processed. And this is what I'm going to pay for, basically, right?
Exactly. And so it's suddenly kind of, when you think about you exposing this to hundreds of users, thousands of users, even if that difference of saying our first query took 12 gig, our second query was less than 1 gig, suddenly it affects price. So it's not just making your queries a lot faster and kind of keeping users happy. It's suddenly actually sort of making it cheaper. So kind of thinking about this query optimization and thinking about how people are structuring it suddenly becomes important, not just to the end users, but also to people managing it and people paying for it.
Got it. So let's list, the different improvements there. First, I don't need to manage any pools, right? I don't work directly on the VM, so I don't need my engineers to put together a workspace like that for the data analyst and for the machine learning and data science folks. Second thing is, I don't have to commit to a certain size of pool, right? I can jump into my serverless, my SQL serverless environment and start running queries on top of the data that sits in the data lake and start running my exploration phase and analytics phase directly from the Synapse Studio.
Exactly.
And I can also monitor. I mean, I can know how much data I processed. I also know who is the submitter, right? How long did it take? Request time. I mean, I have a lot of information right in here.
And there's one more thing that we need to know. Because here, that's fantastic for finding out what's been done. That's finding out what the problem was. And I go, ooh, why did we pay so much yesterday? Oh, it's because we ran 30 terabytes of queries and we didn't do any partitioning, we didn't do any elimination, we didn't do anything smart on it. And one of the real important things people keep asking is saying, how do I put a cap? How do I make sure I don't accidentally spend too much money? How do I actually make sure I can properly budget? So if we go over to the Manage tab over on the left.
Yes.
Okay, and we're in SQL pools already. So we can see our built-in SQL pool.
Ooh.
And then, yeah, exactly. You've got that little fancy icon, which is cost control. And over here, we can set a daily, weekly, or monthly budget and say, I don't want to go over a terabyte a day, 25 terabytes a day. I don't want to go over 30 terabytes a week. And as we saw, kind of because it's pricing is currently $5 per terabyte, that kind of directly translates into how much money you want to be able to spend in a day, month, or week. So super important if you're thinking about doing this, and certainly if you're going to let a whole load of users loose on this, just think about what you want your budgets to be, set them. And yeah, if you start reaching it, maybe it's time to reevaluate and think about how you're doing it. if you're setting a high budget and you're reaching it consistently, maybe you'd be better off having a dedicated SQL pool because you're using it enough to use that cluster. But it allows you to kind of have that free experimentation without putting a load of money in up front, but to have some control over it.
Got it. So this is a big part of data strategies. I mean, when we work with data, we have to put a component to monitor how much it costs us and what do we do. So I see the daily limit here, but I see it's in terabyte. I didn't use terabyte. I reached 21 gigabyte. I didn't even pass that, that first terabyte to put a component. So I guess I'll be good with tuning it into one, maybe even a monthly. Yeah, I think one will be sufficient. All right. What do you think?
I think that's awesome. I think that's us up for time, but I think that's a great intro for SQL Serverless and kind of to get people started and playing with this whole awesome new tool.
Fantastic. All righty. Let me bring back our slides just for the last time. And well, thank you everyone again for joining us today. It was lovely to have you. I hope you learned a lot of new things and you skilled up, and thank you for staying all the way to the end. And for doing so, we want to give you the Builder Badge because you build it with us serverless SQL queries and you ran your own analytics. And Simon, again, thank you for sharing great insights, and thank you for your conversation with Savine. Everyone learned so much about that, so thanks.
Not a problem. Thanks for having me. And again, thanks to everyone for tuning in, asking questions, and yeah, learning.
Awesome. All right, everyone, thank you so much for joining Create Data. We hope you enjoyed it, and we hope you're going to learn a lot more growing up in the future about everything related to data technologies from open source and cloud services and everything related for it. All right, that's time.
Awesome.